Okay, we're integrating now. Now, integration is the opposite of differentiation. It's part of calculus, and basically the powers of x increase. Okay, well, when you differentiate, the powers of x decrease. When you integrate, the powers of x increase. So here we go. So if I'm going to integrate this, you might see this sign here. So it's going to be, where are we? Root x minus 2 over x squared. Now, you'd normally have a dx there, which says it's the powers of x that change. Okay, so with respect to x. All right, so the x cubed should be nice and easy. That's just a quarter x to the power 4. So the power of x goes up by 1, and then you divide by that amount as well, by that power, as it were. Okay, now, unfortunately, with this bit here, and in fact, I'm going to change this to green. I can't. This is horrible. I need to change this to x to the power of half. Same with this one. Before we get there, I need to change that to the 2x to the minus 2. Okay, just it makes it a lot easier, because here we go. When we go up by 1, okay, this becomes 3 over 2x, and I've got to do 2/3. Alright, so I'm almost dividing by 3 over 2, which becomes multiplying by 2/3. Now then, we've got, for the second bit, it's got to go up by 1 and then divide. So I've got 2x to the minus 1 over minus 1. Now, I haven't finished yet, and when we integrate, we go to plus c, because remember, when you differentiate, if there are any sort of just numbers on their own, integers on their own, okay, they just sort of disappear. They don't affect the gradient, do they? So there we go. So you've got to have a plus c, because there may well be an extra number tacked on the end there. Now I'm going to simplify this, and I'm going to go x to the power 4 over 4 plus 2/3. Now, you could write this as x root x, that's absolutely fine, or you could leave it to x to the power 3 over 2. Now I've got a negative there, so I'm going to do this. You could again leave that to the power x minus 1, that's fine, plus c. Alright, so there's the first one. Now, similar with this dy dx here, so I'm going to be integrating this with respect to x, so I'm going to change it straight away to the minus a half, okay, plus, now this x root x is x to the power 3 over 2, it's and then we're integrating with respect to x. So here we go, integrate should be nice and easy. We get 6x to the power of half over a half, okay, plus x to the power 5 over 2 over 5 over 2, okay, plus c. Now I'm going to simplify this, so we get 12x to that plus what are we, 2/5 of x to the 5 over 2 plus c. Now it says find y in terms of x, given that y is 37, x equals 4. So I know that 37 equals 12 times root 4 plus 2/5 x. Now that's x squared root x. Oops, what am I doing? Should be putting 4 in there, shouldn't I? So we go times 4 squared times root 4 plus c. Now I'm going to run out of room if I'm not careful. 12 times root 4 is 24, plus, now we got 16, 32, 64 over 5 plus c. Okay, and that means that, oh crumbs, I've got a lot of adding up. On trouble is I've run out of room. Here we go. So I've got c equals whatever that is, 13 minus 64 over 5. Now I happen to know that that is 1/5. So there we go now. I'm going to have to write it up here, so I should end up with y equals, and I know that's 1/5 because 64 divided by 5, I know 65 divided by 5 is 13, so 64 divided by 5 is going to leave 1/5, and it's 12 and 4/5. So y therefore is 12 root x plus 2/5 of x squared root x plus 1/5. Okay, and there we go. Should be nice and easy. You've got to expect, I know there's no calculator here, but you've got to expect fractions and stuff like that. Alright, and I've managed to do that without too much difficulty. You've got a lot more space. Alright, but remember, when you're integrating and differentiating for that matter, roots you need to turn into fractional indices, and if it's a reciprocal, they've got to be using negative indices. Alright, pretty straightforward. Otherwise it's just literally following. Don't try and do too much in one hit. Basically do it a stage at a time, show each stage of your workings, and you should be fine.